हेलो गाइस। आज मैं थ्योरी ऑफ ऑटोमेटन पढ़ाऊँगा। इसका नाम शुरू हुआ था थ्योरी ऑफ ऑटोमेटन से। जैसे कि तुम देख सकते हो, मैंने हेडिंग भी नहीं डाली है। बेसिक स्ट्रक्चर ऑफ ऑटोमेटा इज theory of computation and automata. Now start with what is sigma. Sigma can be a set, like sigma of set 0 and 1. What is sigma 0 of that set 0 1? Only epsilon, no, nothing else here. And what is sigma 1? 0 1. And what is sigma 2? 0 0 0 1 1 0 1 1. And this, like this, we can go on and on and on, like 0 0 0 0 0 0 0 1 0 1 1, set of all strings till n. Like this. I'm little bit feeling cough, so sorry for that. And what is the cardinality of sigma? Like E0 is 1, E1 is 2, E2 is 4, and so from that you can understand E power n is 2 power n. This is my notes I made, like from my iPad. If you feel bad that notes are not that good, I'm sorry for that. And what is sigma star? Sigma star is subset of like combination of union of all the sets, all the subsets. Is sigma 0, sigma 1, sigma till sigma n. That is the universal set. Sigma star is universal set. Now let's start with the automata. There are three types of automata: finite automata, uh, then we go on to push down automata, and then Turing machine. As we go on to discover new types of languages, we will start to understand those things. Now let's start with finite automata. Finite automata are of two types, जिसके दो तरीके होते हैं. एक में आउटपुट पे ज़्यादा फोकस किया जाता है, एक में बिना आउटपुट ही मशीन रन करती है, एक में आउटपुट दिया जाता है मशीन के रनिंग पे. अपन शुरू में डिस्कस करेंगे डी नो आउटपुट वाले. लाइक वी विल डिस्कस अबाउट नो आउटपुट थिंग्स. DFA, NFA, epsilon, NFA, three parts of this no output automata are there. Now let's start with DFA. What is DFA? DFA's true meaning is deterministic finite automata. In this, every state is determined to go on any particular state if a certain command is given. Like अगर A को 1 देंगे तो वो B पे जाएगा, अगर A को 0 इनपुट देंगे तो वो C पे जाएगा, और कहीं नहीं जा सकता. And now let's discuss about the grammar. what is the proper sets that can be used in these things? Now, what is Q? Q is set of states. Sigma is input, what the input we will give to the machine. Q naught is the start state. F is a final state. I am putting F as multiple states because final state can be more than one state. Now in this case only one final state is there. Del is a transition function from Q cross epsilon to Q. That is the way how we explain it. Now let's discuss what is Q. Q is states A, B, C, D. All these are Q. Sigma, what is sigma? Sigma is the input. And what is the inputs we are giving to these states? 0 and 1. 0 and 1. What is Q? Q naught? Q naught is A. This is the start state. Whenever any arrow from nowhere comes to any state, it is a start state. It's A. A little bit of tearing here because I made this notes on iPad, so a little bit of tearing is there. And what is the F? F I am putting in a set, like it can be many more than this D, but in this case only one final state is there, so I am putting D here. What is del? Del, as we discussed, is Q cross epsilon equals to Q. Like where does state Q gets input goes to which state. This is the transition table. A on 0 goes to C, A on 1 goes to B, B on 0 goes to D, B on 1 goes to A. This is how it works. Now you got what a deterministic finite automata is. Now let's take example of deterministic finite automata. L1. Set of all strings start with 0. Now let's make a deterministic finite automata of set of all strings start with 0. Anything जिसका start 0 से हो रहा है. It can be 0, it can be 0 0, it can be 0 1, it can be 0 1 0 0 1, it can be 0 0 0 0 0 1. Now how we make this thing? Now I made this automata. If A is a start state, if I get 0, it goes to final state. It goes to final state, and then on final state, if I get 0 or 1, it will stay on final state, because we only needed 1 0 and that's it. What if we get we do not get 0? अगर 0 ना आए तो क्या करें? So on that thing we go to other state that is not final state, and that we call a dead state. On dead state, machine stucks there. Like if A gets 1, it goes to C, and if C gets 0 or 1, it stays on C. So there is no end to it. There is no final state in this. Like for example, take an example, 0 0 1. It starts with 0. Our machine should work on this. If I get 0, where does it go? B. Then again I give 0, where does it go? B. Then again I get 1, where does it go? B. And B, what is B? It's a final state. Now let's take example that is not start with 1. A, if it gets 1, where does it go? C. If C gets 0, where does it go? C. If C gets 1, where does it go? C. Dead state. There is no final state. That's how we made a DFA of this problem. Now let's take one more example. All strings over length 2. All strings over the length 2 of input 0 or 1. Now our input is this 0 or 1. Our states are, this is the proper set of strings that are acceptables. All strings over length 2, only over length 2. 0 0 0 1 1 0 1 1. If it gets 0 or 1, it goes to B. If B gets 0 or 1, it goes to C. And that is our main condition. 2 strings, it should only be 2 strings. It could be 0 or it could be 1. So C is the final state. What if C gets one more 0 or 1? We do not want more than 2 length. So if on getting 0 or 1, it goes to D, and if on D gets 0 or 1, it stays in dead state, because we do not need more than this. So this is a dead state. Let's check this example. 0 0. A on getting 0 goes to B, B on getting 0 goes to C, and C is the final state. This string is accepted. DFA, let's take one more example. DFA that accepts all strings over A and B contains AABB. All the strings that contain AABB, we can accept this thing. It can be AAABB. It can be AABBBB. It can be AAABBBB. Anything can be there. So let's start with this. If we get A, A is the start state. If we get A, we goes to B. If we get A, it goes to B. If we get A again on B, it goes to C. If we get B, it goes to D. If we get B, it goes to E, and this is the final state. Now let's check other inputs that it could go. Like if we start with A, it if on start state we get B, it stays in A. We do not need to proceed on this automata because this machine is checking AABB. If we get B, it stays in B. Now A, on getting A, goes to B, and if B gets B, it goes to A. It can be B, A, B, B. That's why it goes to B. If D gets A, it goes to B, because we can still get A, B, B. This pattern can still work. On final state, if gets A and B, it stays in the final state. That's how this condition is done. If the condition is not AABB, like question was, if question changes that we do not need string AABB, what we will do? We will just change every state to final state and the final state to normal state. That's how it just changes. Now we came to the next topic, regular languages. Regular languages have properties like this: A union B. A union B is x cross A, x cross B. A concatenation B is x y. X belongs to A, y belongs to B. A star is x1, x2, x3 till xk. K0, x belongs to A. NFA. Now we came to the next topic, that is NFA. Non-deterministic finite automata. This word itself explain what is non-deterministic finite automata. If we if we get 0 on A, it can stays on A. If we can, it can still go to C if it gets 0. It can goes to 1 if it can goes to D if it gets 1. It can goes to B if it gets 1. So there is no decided point that where will it go. It can go anywhere. It can go in anywhere to anywhere state if it gets epsilon also. Next state can be random or parallel. This is the method of this thing. Let's take example. Set of all strings end with 0. Strings that end with 0. Now in automata, if we get 0 or 1, it stays on A. If we get 0, it goes to final state. We, like for example, we can take strings 0, 0, 1. We got 0, it stays on 0. Like 0, 0, 1, 0. If it gets 0, it stays on 0. A. If it gets 0, it stays on 0. If it gets 1, it stays on A. If it gets 0, it goes to B. Now string is accepted. This is the proper regular the terms used in this. Q is states, sigma is input, Q0 is starting state, F is final states. Del here changes. Q cross epsilon is 2Q. A cross 0 is A cross 0 is B, A cross 1 is A, B cross 0 is phi, B cross 1 is phi, A1, A, B, A, phi. It's a complicated topic. I'll explain you here. Example 2. L. All strings starts with 0. It can 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1. Now I made this automata. If we get 0, it goes to final state. If it gets 0, it goes to final state. On final state, if it gets 0 or 1, it stays in final state. In this, we do not need to check where does it go on 1. Like in deterministic finite automata, we have to define where does it go. But in this, we do not have to define this thing. But it goes to phi if it gets 1. That is the beauty of NFA. Now we'll discuss NFA to DFA. Like, can we change NFA to DFA? Every NFA can change to DFA, but every DFA cannot change to NFA. That is the problem. Let L is set of strings 0 1 start with 0 sigma. This is the input. NFA is this, like we took previously. If it gets 0, it goes to final state. If it gets 0 or 1, it stays in final state. Like, this is the transition table of the NFA. Now what does a DFA do in this? We'll make a one more state, that is a dead state, and it stays in C. This is the proper transition table of a DFA. Now we came to the next topic, minimization of DFA. Thank you so much. I explained you NFA, DFA and regular languages, few things in this video. We'll discuss more things in next video. Thank you so much. We'll discuss about minimization of DFA. Thank you so much.